Electromagnetic fields. In this, first we will discuss about vector analysis part 1. In this part 1, we are going to discussing about multiplication of vectors using dot product and cross product. So in the next video, we are going to discussing about different types of coordinate systems and their limitations and differential elements. Vector analysis. What is scalar and vector quantities? Most of the quantities encountered in electromagnetic fields can easily be divided into two classes, scalars and vectors. Scalar, a physical quantity that can be completely described by its magnitude is called a scalar. Some examples of scalar quantities are mass, time, temperature, work, electric charge. Each of these quantities is completely describable by a single number. A temperature of 20 degrees Celsius, a mass of 100 grams, and a charge of 0.5 coulomb are examples of scalars. In fact, all real numbers are scalars. Vector, a physical quantity having magnitude as well as direction is called a vector. Force, velocity, torque, electric field and acceleration are vector quantities. A field is a function that specifies a particular quantity everywhere in a region. Unit vector. Any vector can be represented by the magnitude of the vector multiplied by its unit vector written as an. So, vector A is equal to mod A into an. Here an is the unit vector of this vector. So, mod A, it is nothing but magnitude. A unit vector has the direction of the main vector is of unit magnitude. It is the ratio of vector itself by its magnitude. Thus, magnitude of unit vector is 1. How to multiply vectors? So, that is multiplication of vectors. So, there are two types of vector multiplications. One is scalar product, also known as dot product. Second one is vector product, also known as cross product. First, we will discuss about dot product of two vectors. Dot product of two vectors is a scalar quantity having the value equal to the product of magnitudes of two vectors and the cosine of angle between them. If A and B are two vectors having an angle theta between them, the dot product between A and B is A dot B is equal to mod A mod B cos theta. Let us assume vector A is equal to capital AX into small ax plus capital AY into small ay plus capital AZ into small az. Example A is equal to, vector A is equal to 2ax plus 3ay plus 4az. So 2 is the magnitude along x-axis, 3 is the magnitude along y-axis and 4 is the magnitude along z-axis. In the same way, vector A it is equal to capital AX into small x plus capital AY into small ay plus capital AZ into small az. So capital AX, capital AY, capital AZ are magnitudes, small ax, small ay, small az are unit vectors or direction of the vectors. In the same way, assume vector B is equal to bx into ax plus by into ay plus bz into az. Example B is equal to 4ax plus 5ay plus 6az. So 4 is the magnitude along x-axis, 5 is the magnitude along y-axis and 6 is the magnitude along z-axis. So here capital AX, capital AY, capital AZ, capital BX, capital BY, capital BZ are magnitudes and AX, AY, AZ are unit vectors along the XYZ axis. Multiply above two vectors with dot product. A dot B. So substitute A and B. So it is the total vector A and it is total vector B. So after multiplying these two vectors A and B, we are going to getting 9 terms. So vector A is having 3 terms and vector B is having 3 terms. So 3 into 3, 9 terms we are going to getting. So these are nothing but first we are going to multiplying. So first term into first term and first term into second term and first term into third term. So in this one, so first term into first term, that is Ax into Bx. So these two are magnitudes. Magnitudes can be multiplied directly. So along with the magnitudes, we are also having unit vectors, that is Ax into Ax. These two are multiplied with dot product. So capital Ax into capital Bx, these two are magnitudes. And now multiply unit vectors Ax dot Ax. In the same way, so first term into second term. So first term into second term, that is Ax into By. Ax into By. So along with these magnitudes, multiply unit vectors Ax dot Ay. In the same way, first term into third term. Similarly, so second term into first term, that is Ay into Bx, Ay dot Ax plus Ay By, Ay dot Ay plus Ay Bz, Ay dot Az plus AZBX, AZAX plus AZBY, AZ dot AY plus AZBZ into AZ dot AZ. So these are the 9 terms after multiplying the two vectors A and B. So here multiplication of magnitudes are simple, multiplication of unit vectors is different. Here what is the value of Ax dot Ax, Ax dot Ay and so on. As per the dot product formula, Ax dot Ax is equal to, it is mod A mod B cos 0 degrees, means so mod of Ax equal to 1, mod of Ax equal to 1. These two are separated by angle of 0 degrees. So Ax means two are parallel, two are on the same axis. So angle between the two is nothing but 0. So that is cos 0. So mod A mod B cos 0 means 1, that is equal to 1. So the Ax dot Ax is equal to 1. And Ax dot Ay is equal to how much? X and Y are separated by angle of 90 degrees. So that is mod A mod B cos 90 degrees, that is equal to, so mod A mod B and cos 90 equal to 0. So total is equal to 0. So Ax dot Ax is equal to 1. Same Ay dot Ay is equal to 1. Az dot Az is equal to 1. If the two vectors on the same axis, then the dot product of two vectors is equal to 1. Ax dot Ax is equal to 1. Ax dot Ay dot Ay is equal to 1. Az dot Az is equal to 1. Ax dot Ay is equal to 0. Ay dot Az is equal to 0 and Az dot X is equal to 0. So when two vectors on different axes, then dot product of these two unit vectors is equal to 0. So because so two are separated by angle of 90 degrees, that is cos 90 equal to 0, then so Ax dot Ay or Ay dot Az or Az dot Ax is equal to 0. So dot product of unit vectors on the same axis is equal to 1 and dot product of unit vectors on the different axis is equal to 0. After substituting the values of above unit vectors, then we are getting the value A dot B is equal to Ax into Bx plus Ay into By plus Az into Bz. It is the total value of multiplication of the two vectors A and B. So A dot B is a scalar quantity. We are not having any unit vector. If you are having a unit vector, that is going to representing the value of direction, but here there is no direction. So it is a scalar. A dot B is a scalar. Now laws of the dot product. What are the different laws? So A dot B equal to B dot A. If you are multiplying A dot B or B dot A, that is equal to same. A dot B into B plus C is equal to A dot B plus A dot C. Also a into a is equal to a square. Now cross product of two vectors. The cross product of two vectors a and b is another vector whose magnitude is the product of magnitudes of a and b and the sine of the angle theta between a and b, and whose direction is the direction of a right hand screw as it is turned from a towards b through theta. Thus you can write a cross b that is equal to mod a mod b sin theta into an. Here an, this an represents unit vector normal to the surface of AB. So cross product of two vectors is a vector, it is not a scalar. So an is the unit vector normal to the surface of vectors a and b. Let us assume vector a is equal to ax into small x plus ay into small ay plus az into small az. So example, a is equal to 2ax plus 3ay plus 4az, and also assume b is equal to bx into small x plus by into small ay plus bz into small az. Example, b is equal to 4ax plus 5ay plus 6az. Here capital Ax, capital Ay, capital Az, capital Bx, capital By, capital Bz are magnitudes along Ax, Ay, Az, unit vectors Ax, Ay, Az, okay, which are along XYZ axis. So multiply above two vectors with cross product. So a cross b, substitute a and b. So here also, so vector a is having three terms, vector b is having three terms. So by multiplying these two vectors, we are going to getting 9 terms. Multiply the same first term into first term, and first term into second term, and first term into third term. So ax into bx, ax cross, and also multiply the unit vectors ax cross ax plus ax into by into ax cross ay. So multiply the two unit vectors with cross product. Okay, so like that multiply all the vectors, then we are going to getting. So here multiplication of magnitudes are simple as they are scalars. Means ax dot ax into bx, ax into bx, these two are nothing but scalars. Directly you can multiply. Means so 2 into 4, 8. Directly you can multiply. But ax cross ax, it is different. Along with the magnitudes, we have to multiply these unit vectors. So with cross product. So whereas ax cross ax is how much? And next ax cross ay is how much? Ax cross az how much? Ay cross ax how much? So these unit vector multiplication using cross product, if you know, then the total value can be analyzed easily. So but multiplication of unit vectors is different. That how to multiply. So it is also same as cross product formula. So as for this, as for the cross product formula, ax cross ax is equal to mod a, magnitude of ax is nothing but 1, magnitude of ax is 1, sine 0, these two are along x-axis, so angle between the two is nothing but 0 degrees into an, so sine 0 means 0, so total is nothing but 0. So ax cross ay, so mod ax mod ay, so magnitude of x is 1 and magnitude of ay is 1, so sine 90, angle between this x and y is nothing but 90 degrees, so sine 90 is equal to 1. So here ax cross ay is a plane, xy plane, so to this plane, so z is perpendicular, so we can say that az is perpendicular, so mod a mod b sine 90 into an is nothing but az, so total is nothing but az, so we can write az. So ax cross ay is equal to az. The unit vector perpendicular to xy plane is az. Ax cross x is equal to 0 and ay cross ay is equal to 0, az cross az is equal to 0. Ax cross ay is equal to az, ay cross ax is equal to minus az, if the two are reverse. Ay cross az is equal to ax, if yz plane, if one is along y axis, one is along z axis. It is nothing but yz plane. So unit vector perpendicular to this yz plane is nothing but x axis. The same way, z cross y is nothing but minus ax. So az cross ax is equal to ay. Ax cross az is nothing but reverse, but minus ay. Like this we can write multiplication of unit vectors. If we substitute all these values in the above equation, then we are going to getting, so this ax cross a cross b is equal to ax into by into az minus ax bz ay minus ay bx az plus ay bz ax plus az bx ay minus az by ax. So here, so we can take the common ax unit vector ax, we can take common. Here we are having one ax term, so ax term, and here also one is ax term and ay term, and here also we are having ay term. So here we are having az, and here also we are having az. So take the common ax, ay, az, then we can write the two equations. A cross b is equal to ay bz minus az by into ax plus az bx minus ax bz into ay plus ax by minus ay bx into az. So that is nothing but, so a cross b is a vector here. So it is the magnitude along x-axis, it is the magnitude along y-axis, and it is the magnitude along z-axis. So a cross b is a vector, it is not a scalar. So sum is along x-axis, sum is along y-axis, sum is along z-axis. So cross product, loss of cross product. So a cross b is equal to minus b cross a. These two are not equal. Magnitudes are equal but opposite direction. A cross b and b cross a, two are having equal magnitude but opposite direction. So a cross b is equal to minus b cross a. So in vector product, the associative law doesn't hold. That is, a cross b cross c is not equal to a cross b cross c, but the distributive law holds. A cross b plus c is equal to a cross b plus a cross c. An example of the cross product is a force on a current carrying conductor placed in a magnetic field. So it is nothing but the diagram which shows the cross product. One is along A and one is along B, means so these two are on one plane. It is nothing but plane. Suppose if it is along x, if it is along y, so it is nothing but xy plane. Okay. So if A is moving towards B, A cross B means A is moving towards B, resultant is moving along z axis. A cross B, when A is moving towards B, resultant is moving perpendicular to the surface. So to this plane, A and B is a plane, to this plane, so AN is going to be normal. So it is perpendicular to the surface of AB. So it is according to a right hand screw rule. When screw is going to be rotated, we are rotating the screw in horizontal, but its movement is going to be vertical. You need to learn about multiplication of unit vectors. Multiplication of unit vectors, ax cross ax, ax cross ay, ax dot ax, ay dot ay. So these multiplication of unit vectors is important.